Today's lesson is a brief review of ionic and covalent bonds. This is not necessary if you already remember this stuff, but if you want a little brush up on ionic bonding and covalent bonding, this would be a great little video to go ahead and watch. Because in this chapter we're going to cover is we're going to go into more detail about bonding and chemical bonding and how bonds form. We're going to basically get into the more depth. So if you forgot this, here we go. Alright, so ionic bonding is based on the fact that we create ions, that ions are going to be formed. Okay, so if ions are formed, we have to have electrons transferred, and this is kind of what we were talking about with ionization energy in that chapter on periodic trends and stuff. The fact that certain elements are better at losing electrons and others are gaining them. So once the ions are formed, that's when the bond takes place. So for the example in sodium chloride, that sodium electron that we have here goes to the chlorine atom, and since this is a negatively charged particle, it's going to leave behind a positive charge on the sodium and a negative charge on the chlorine, and that's what's going to basically pull these two particles together and create a sodium chloride bond, okay, which we would neutralize and we would just write it as NaCl. Okay, so we form at the very essence of ionic bonding, the bond that's holding these two atoms together is based on the positive and negative attraction force. Okay, so when we have this positive charge and a negative charge, what tends to happen is those positive and negatives just keep attracting each other. Think about it. If I have a positive charge, this particle here is positively charged, wouldn't it make sense that all of these negatively charged particles would surround it? Right? You would get all these negatively charged particles to bond, and so with ionic bonding, the bonding just keeps occurring over and over and over throughout the crystal structure, because if I have a positive charge, negative charge here, then I would have a positive charge that bonds here and a positive charge that bonds here, and it just keeps repeating itself over and over and over throughout the entire structure. There's really no end to the ionic compound is what I'm trying to say. So what's holding these atoms, and I should say actually these ions in this crystal structure, and this is an example of sodium chloride. Sodium is smaller, chloride is bigger. Again, remember losing electrons and all that kind of stuff. The bond that's keeping this salt together, this is table salt, and this would be the breakdown of what it looks like at the molecular structure, at the atomic structure, is the ionic bond. So you have an ionic bond here, 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 all throughout this whole crystal structure. You have this ionic bonding throughout, so there's no end to it. Now if we contrast that to molecular bonding, or what's called covalent bonding. So we can use two terms here. We can say that this is molecular bonding or covalent bonding. So molecular or covalent. And the difference here is that the atoms that come together are not going to transfer electrons, but they're going to share electrons. Now this makes things a lot more complicated because of the fact that there's no ions that are formed, there's no attraction between the particles, other than the fact that they're attracted by creating that shared electrons. This is always going to be between two nonmetals, and it's going to form molecules. No ions are formed here. Okay, so we form molecules. All right, so when we have something like water come together to form, the hydrogen has an electron. Well, oxygen has an empty space for its electrons. We'll talk more about this when we get to Lewis structures. And we have hydrogen here. What's going to happen is they're going to share these electrons. These are going to create what's called a bond. And we get a water bond to form between these two. And this is what we would call the water molecule. Now there's no charge that's holding them together. It's the fact that when we look at that hydrogen, it has a 1s orbital. Oxygen has the 1s, 2s2, 2p4. Well, if we look at that 4, that 2p4, if I draw that over here, that 2p4 orbital has those two empty spots in it. So you got 1, 2, 3, 4. There's two empty spots for the hydrogens to bond into, and they share and overlap in this region and in this region. That's why we get two bonds, and then the 1s from the hydrogen fits into those locations, and you get this shape to your molecule. You get a hydrogen, water molecule to form based on the sharing of electrons, not forming ions. So what you end up with, and here's the big difference, is you get this little glob or group of molecules that act independently of each other. Okay, there's two different kinds of forces going on in our water molecules, or in our sample of water. You have the force inside the molecule that's holding the atoms together. Let's do a different color there. Let's go ahead and do green. So there's a force holding the hydrogens and the oxygens together. Right? There's a bond here which we call the covalent bond that keeps the molecule together. Then there's another force we're going to talk about in a later chapter that keeps the two water molecules together, that bonds all of these together. So there's different kinds of forces that are happening inside the water than we have happening inside the ionic compounds. And the same thing goes on with something like this. If we have oxygen, so this is O2, they bond together to make oxygen molecules that are going to stay together as individual little units or groups. Same thing with carbon dioxide. We're going to talk about why water has this shape and carbon dioxide has this shape in the next few lessons. All right, so that's pretty much the review of covalent and ionic bonding, and we're going to try to explain covalent bonding in a lot of detail. We'll talk more about this fact that there's two types of covalent bonds that's going to come up in a later lesson, the fact that some of these bonds can be polar and nonpolar. So don't worry about that for the review. I hope that helps you guys, and we'll get started in the next chapter. Thanks.